Hello friends, welcome back to my channel. In today's video, we are going to simulate A/B testing of machine learning models. Now, this doesn't only apply to machine learning models, it can be AI models. A/B testing is actually from statistics, and machine learning and AI models adopted it. So we will simulate A/B testing of two different machine learning models and how we can pick the best based on our users' feedback. So we are going to deploy a logistic regression model and a random forest model using a Flask-based API. And then we will route traffic to those two models via an Nginx load balancer. So the Nginx is going to route 50% traffic to model A and 50% traffic to model B. And then we will have customers or clients interfacing with these two different models. Even though both models may be of the same type, in our case, logistic regression and random forest are both classification models. They will interact with both models and determine which model works best for them. Now, the feedback that they will give, we will record it or we will log it and compare it to the prediction that our models actually makes as well. And then we will check the accuracy, not of our model per se, but of the responses that we are getting from our customers compared to the prediction that our model actually gives us. So building a model and deploying it is one thing, but it's actually working in real life is another thing. You may have a 99% accuracy model, you deploy it in real life and it's horrible. And that's because when you're dealing with human beings, there are so many variable factors involved. Suppose that it's rather two products, let's say green apple and red apple. If more customers prefer the green apple to the red apple, you know which apple you should stock more on your website or at your store. In that same route, since we are using machine learning model, let's think of these two models classifying between transactions that you are getting on your banking app, whether they are fraudulent or not. If customers based on, let's say, model A say that that particular model helps them catch fraudulent transactions better than the other, then you know as a machine learning team or as a data science team or AI team, that model actually works best in real life compared to this other model, let's say model B. Of course, all our codes are written in Python. Also for the load balancer, you can use any load balancer. We are just opting for Nginx as our load balancer, so either way is still fine. Enough of the intro. Now let's get into it. Okay, now first we need to set up our environment. By the way, this is our GitHub repository. You can follow this GitHub repository for any new projects. You see the new repository, A/B testing, Flask, Nginx, Docker Compose. That will be a repo for this project. If you go in here, have a README file only. By the way, I've cloned this README file. Just click on code, copy this command with this button here. And then locally, you just type git clone, and then you paste that link that you copied over here. Press enter, and that should clone your repository. I've already cloned it. This is my README file from the GitHub repository. Same thing here. Now I have all the codes provided in here, so there's no need to look elsewhere for this project. We want to set up our environment. So first, let's look at the requirements. Now we need Python. That's what we're going to use for building the classification model. We need Flask. This is what we will use to expose our API for inference model. And then we need Nginx. Nginx has so many uses. Web server, load balancer, reverse proxy. You can use it for so many things. In this project, we are going to use it as a traffic load balancer between the models that we are going to build. And then we will need Docker and Docker Compose. So we will write some Docker files to containerize our two models, but we want to also orchestrate it automatically with a single script. That's why we need Docker Compose, so that with a single command, we can get all those two Docker containers from the models up and running. And then we will need Streamlit for visualizing the model feedback performances that we are trying to look for in our A/B testing. So first, we will need these directories. So I'll copy this command, run it here on my terminal. I've created the 4 directories here. Now I want to isolate this project from my local Python environment. So I'm going to create a Python virtual environment. Use Python-m to create a virtual environment. And the name for our virtual environment is going to be abtest vmv. I'll copy this command here. Now, there it is. If you go in, you see Python binary files and stuff. Now, creating it is not enough. You need to activate it so that it takes over everything that we run for this project on that Python environment. So use the source command to activate it. And now you see that from your terminal, you see abtest vmv. Next, we need some requirements. Now I'm going to create the requirements.txt inside the API directory right here. So let's cd create requirement.txt file with this command here. I'm going to open this here. These are the packages that we are going to need. So just copy this, paste them in here, save it. To install it, you would use pip install -r requirement.txt, and that should install all the packages. Okay, all the packages are installed. So next thing, we will look at how to write and run our model scripts. Let's first clear the screen. Now to create our model scripts, already remember we created the model directory right here. At the moment it's empty because we are in the API. I'll go back and then I'll cd into the models directory. There's nothing in here. And then I'll create 2 Python scripts, one for the model A and the other one for model B. In our case, model A is the logistic regression model and model B is the random forest model. So I have the model A script right here. So I'll open the scripts, paste it in here and save it. Open model B. This is it right here. Copy this and save it in here. Now let's go through it briefly. Now this contains the famous iris dataset. So that's where our data is coming from. And this is our model we're using, logistic regression, with 200 maximum iterations. Here's where we fit the model. We save it as model_a.pickle. Similar thing in the model B, exact same data set. The only difference is now it's a random forest classifier with 100 estimators. We fit the model and then we will save the model as a pickle file, model_b.pickle. Just use Python 3 to run those training scripts. And this should also train it. In our files, our models should be saved as a pickle file. When you check the models directory, you see model_a pickle, model_b pickle. So these are our model files. For our next stage, we will look at how to create Flask APIs to expose both models. Okay, Flask APIs are a way we can communicate with our application or the model. In this case, model_a.pickle, model_b.pickle. API is just an application programming interface. So I've built a Python model, which is a machine learning model like this, and it's all encapsulated inside this single files right here as the model. I need to communicate with that model. So how do I do that? And that's where an API comes in. And in our case, we are using Flask API. But in the machine learning world, Flask API is pretty common. We need to go into API directory that we created earlier. So let's go back and cd into API. Let me clear the screen here. Now inside the API directory, there's only the requirement.txt. So I'm going to create 2 more files. Those will be the Flask API scripts. For both model A and B. So for the app model A, I have the code here by the way. Just copy it up to this point. Copy this. And now this is for model A. Paste it in here. Save it. And then we have model B. I'm gonna copy this up to this point. Save that. Now let's briefly go through the script. It's essentially the same scripts in both A and B. The only difference is we are interacting with different models. In here, we are loading the model underscore A pickle. In this one, we are loading model underscore B.pickle. By the way, remember the iris dataset is actually about the dimensions of flowers and how to classify them based on the features of that flower, which type of flower it is. Maybe quickly on Google, you can search the iris dataset. Go to the UCI machine learning repository here, and this are some information about it. So there are 4 features. Now those features are sepal length, sepal width, pedal length, and pedal width right there. We are using it to predict the class of that flower. The class could either be setosa, versicolor, or virginica. So these 4 features here are gonna be in the form of items separated by comma. Here is where we will use the model to do some prediction. And then the information that we get from people using the model, we will log it to save the time. If he uses this endpoint, that will be saved as model A. Our features will be the feature data, which is what we specified right there. We will get the prediction and then the feedback. So we save all this information. By the way, we will analyze this data later on. Next, we will look at how to set up Nginx as a load balancer for the 2 models that we've created. In Nginx, by default, we route traffic the same rate if you have multiple servers. And that's what we call round robin. To do that, you will first create a configuration file, which we are going to call default.conf inside the Nginx directory. It's currently empty, so let's go back and let's go inside Nginx. There's nothing in here. I'm going to clear the screen. Default.conf, you can give it any name, but it has to be .conf for configuration. Now for the content, I've provided it over here. Copy this. Paste it in here. Now, to write this Nginx config file, you would need some events, and then you need the traffic that you are routing. We are only routing HTTP, HTTP block. Now, if you want to route any traffic to some servers using Nginx, you need to specify your upstream. In our case, we have 2 different models, and we are routing it through Nginx. So those will be our upstream. We are giving it some generic name. This name doesn't really change anything. You can give it any name you want. If you call it backend, then inside the server over here, your proxy path should also be http://backend. And then we are calling the first server model underscore A, which is for the first model. But this default.conf is actually for the Flask APIs that we created. So their listening port is still the same, 5000. This also has port 5000. That's why they both have :5000 here. Now, if you don't specify any weight in Nginx, it will pass equal amount of traffic through both models or both servers. You can also specify the weight, but then use the exact same values for either of the servers, like we've done currently 1:1. That means in our case, 50% for model A, 50% traffic for model B. If you want different level of traffic, you just need to change this value. Let's say I change this to 8 and I change this to 2. This means route 80% of the traffic through model A and only 20% of the traffic through model B. If you want 40/60, you just put 4 here, 6 there, and that will do the exact same thing. A/B testing, we need equal traffic. So either you specify the equal weight or get rid of them totally. By default, it will traffic it equally. This is an HTTP block that we're using here, and that's port 80. If you go to our models, based on our Flask applications, they are all routing via /predict. That's why we have the location as /predict. All right. In our next stage, we will look at how to containerize our Flask-based applications, which are our APIs. And for that, we are going to use a Docker file and a Docker Compose file. Now, because we need to containerize our Flask-based applications, we need some Docker files. Go to the project root directory and create these Docker files. By the way, remember, we have two applications here, so we need two different Docker files. I didn't want to put them together so that we can containerize them separately as two different servers and then route traffic through them via our Nginx load balancer. This is our parent directory where everything is. I'm going to create my Docker files. The touch command like that. You're going to open this and edit them. Copy this. Paste it here. Docker file B. Is it right here? Copy this. Paste it here. In Docker, whenever you want to build a Docker image, you will need some base image. In our case, an image that is quite light because we are building stuff on top of it. All these are instructions that we are piling on this base image we have here. It's always a good idea to use a very lightweight image. Now, our application is Python based. Yeah, we're using Flask API to package it, but it's still Python, right? So we need a Python image to make it easier. So we are using Python, and trust me, there are so many images out there. If you go to your Docker Hub account, if you don't have one, you can create one for free and search for Python. This is the official Python images right here. You go to tags. These are all different Python images. There is millions of them. We need a light one, so that's why we are using the Python 3.10-slip. When we create a container, we will need a working directory, and we are setting that as /app, a name that is easily recognizable. And then we are going to copy the API directory that we have here. Remember, it's the API directory that has our Flask API codes, which is the app_model_a.py and that of b.py, as well as the requirements.txt. When we go inside the container, we need to still be able to run the requirement.txt for this whole application to run. And this is going to copy it into the current directory, which is what we set as the working directory /app. And then it's going to go into the models directory and look for model_a.pickle, which is the first file here. And it will copy it into our current directory. And then it will install all the requirements. Now, CMD means command. Now, this helps you to execute commands inside the container, right? Now, of course, if you have a Python script and you want to run it, you'll use the command Python and then the name of the Python script. And that should start up our whole model or application inside the container. It's essentially the same thing here in the B. The only difference is this is model b.pickle. Next stage is how to use this Docker file alongside a Docker Compose file that we are going to write, alongside the Nginx configuration, because the Nginx is also going to be some container, all of it together. And for that, we need a tool like Docker Compose. Now, to use Docker Compose to orchestrate this whole thing, you need to first create docker compose.yaml. That's going to be our Docker Compose file. Now, that should also be inside the same root directory. That's our Docker Compose file. I'm going to open it. Now, our Docker Compose is going to do this. First, it's going to build the two Docker files that we created. It will use that to build the images. One for model A, one for model B. And then it's going to install the required Python packages. Of course, inside the Docker files, you see the requirements.txt command there with the pip. By the way, the run here basically runs a shell script, like the commands that we run on our shell in our local bash environment. And then it's going to use different Flask entry points using the command override. This is a command entry point. This will run the model A, and then we'll override it and then use this command to run model B. So one container after the other. And then it will use Nginx to route our traffic 50/50 through those two models. So let's see our Docker Compose script. I'm just going to copy it. Paste it in here. So in a Docker Compose file, you first specify the version. We call a single task a service. This is the service for model A. This is a service for model B under the label model_B. And then this is a service for our load balancer, which is under the label Nginx. For model A, we are calling this a build, and context, you see dot. The dot just means that we are building using the Docker file inside the current directory that we are in. Remember, we are in the root directory. That's where all the Docker files are, right here. And then each Docker file name has to be specified. This is under model A. So the Docker file is dockerfile.model_A. You need to give it some container name. We are calling it model_A. We want to save all the logs to our model. Remember, we saw that inside the Flask app right here. All the log entries, we want to save them for analysis later. So we need somewhere to save it. And you use volumes to store files inside the container. So logs mounted to logs. And then for the ports, this is a Flask API. Flask API listens on port 5000. But for the traffic coming through the port 5000, it has to come from a different port number. So for model A, we are giving it port 5001. For model B, we are giving it 5002. Now the command here is the exact same as the one above, just change the labels to B. And then we have our Nginx. We don't have a Docker file for Nginx. Okay, it's not necessary. So what we can do is, for the Nginx, start with a Docker image. Again, in your Docker Hub account, you can search for Nginx. These are the official Nginx Docker image tags here. The one that I'm using is Alpine. These are all Alpine images. This is the one I'm using. And then of course we are using HTTP, so port 80. And for our Nginx, we are using port 8080. And then we need our Nginx configuration that we created earlier inside the default.conf, and that is inside the Nginx directory. So we are mounting Nginx/default.conf to a location where Nginx can actually identify inside the container. So that's the compose file. Now to run that compose file to build our containers, we just use the Docker Compose app --build. It has started running, going through the logs. It started building the image from the Docker file for model A. All of these are for the model A, okay? And it finished building at this point. And then it starts building the Docker image for model B. That also finishes somewhere here. And then it starts using Docker Compose to create an orchestration between those two models. Once it's done, it creates the entry points and it starts directing traffic. So you see here that it starts serving the model A and then it starts serving model B right there. I'm gonna create a new one. If anything, we can go back to this. Now in our next stage, we are gonna send some inferences to the /predict endpoint where all the predictions will come from. That's the route. Let's send some requests to our application endpoint. So our applications should still keep this running, the Docker Compose that we run, and we are going to use the other bash terminal here. Now remember, in our Flask API script here, this is a route /predict, and the method we use here is post. So when you send this curl command, let me copy it for now. Copy this, paste it here. Curl sends a traffic to a web page or web link. It's a post and it's running on localhost 8080. Now remember, 8080 is a port that Nginx uses. So every traffic has to go through the Nginx before it reaches the actual models themselves. And of course, we are using a local machine, or you can use the 127.0.0.1, which is the same as localhost. And the path is /predict. And then for the content type, we're using application/JSON. We are providing some features, and then we will give a feedback whether it's true or false. So press enter, and you see that it's logged this information down. This customer predicted true, and this went to the model A, and the prediction is 2. Now this prediction number, even though it's an integer, remember on the data set for iris, the integers for prediction are representing these types of flowers. Either it's virginica, versicolor, or setosa. Usually, setosa is 0, versicolor is 1, and virginica is 2. That's our first login. By the way, when we log, over here, it creates log directory and then predictions.log file for our login. So you see that a new directory is created right here, which is logs. If you go in there, you see predictions.log. Click on it, and you see the information that we created here is right here. That is one. Let's run a couple more. So I'm gonna run this. And everyone we send, you see that new logs will be appended. So the next one, let me copy this. Let's open the log and check it. If I paste it here, press enter, that is the log. I have a few more. So think of this as our customers interacting with the products on our website. Paste it here again, send it, and that also appends another one. So this is the information so far, and you can do more if you want to. But this is the log file that we can analyze later on to get our A/B testing results. So that's going to be our next stage, how to analyze the logs to finally arrive at which model is working best. Now that we've sent some post requests to our API, I'm just going to clear the screen for now. Now it's time to check our predictions.log file here and analyze it to see which model is actually performing best so that we focus more attention on that. I'm going to create a script called analyze abtest.py right here. By the way, I'm creating this inside the root directory as well in this exact same location. And I'm going to open it. Now the content is right here. So I'm going to copy this. That's going to load predictions.log file content and analyze it in a single place. So what this is doing here is just loading the predictions.log file. Clearly, there are no headers here, so header is none. Even though there are no headers, each column or variable or string after a comma represents something. And these are the stuff that they represent. These are the names, timestamp, model, features, prediction, and feedback. Now, this is going to take the feedback and then compare it to our predictions. So this is our prediction, and this is the actual feedback our customers give. So we compare them, and then we will group them by models, and we will take the average of it. Now, this will be accuracy, but not the accuracy of our model itself. It's going to be the accuracy based on our users' feedback, and then we will print that over here. Python or Python 3, analyze abtest.py. Okay, I think I need to activate my virtual environment one more time with the source command here. Okay. It's activated. Run the analyze.py. Now, when we analyze it, you see the model accuracies based on our feedback from the users. Model A has roughly 0.67, which is 67%. And model B has 0.50, which is 50%. What this means is more of our customers prefer model A. Let's say this is some models predicting fraud. If one model helps customers catch fraud more of the time, like this model A here, which is the logistic regression model, then we should rather use that more than the model B, which is the random classifier model. Now, if it's a product, if A is green apple and the B is red apple, clearly customers prefer red apple more. So we should have more stock of red apples. That's what this means. Now in the next stage, we are going to visualize these metrics here using Streamlit. I'm going to create another script here called the Streamlit_app.py. Now in here, we are going to show the number of predictions that we are getting per model, the accuracies based on the feedback, and we are going to generate some chart. I have a Streamlit script here that I'm going to copy. So this is creating a page layout. This is our title, and this is going to load the log file. I've actually added the comments here. To run the Streamlit app, you run Streamlit and then the name of the application. So Streamlit run, and the name of the app is Streamlit_app.py. And this creates a link right here. You can copy it, go to your browser, paste it here and press enter. And this is our Streamlit app. Now for model A, we got 3 positive feedbacks. And for model B, we got 2. 50% accuracy for model B and 67% accuracy for model A. Now remember, we were tracking the timestamp or the date time. So you see that on Tuesday, which is today, you have these data points for model A and B. Before we leave, let's do a little cleanup. So I'm going to close this page. By the way, I have everything on the GitHub repository here. Control C to exit out of the Streamlit app here. And then I will go to the other bash terminal. Exit out of this with Control C, or Docker Compose down. That should also shut it down. Before I push, I'm going to remove the virtual environment that we created. rm-rf, our virtual environment is AB. Use tab to complete it. That's our virtual environment. So I will remove that. Okay. Yeah, everything looks good. So I'm going to save the README, git add everything, git commit all the codes, and then I'll do git push. All right, go to your repository, refresh this, and you should see every file or directory that we use right here. And this is our README. Like, comment, and subscribe to my channel for more videos like this. I'm still a new channel. I'm trying to grow. So like, comment, and subscribe to my channel for more videos like this. And I'll see you on the next one.